What is a streak? Is this a streak? Yes, it's a win streak of 10 games. Is this a streak? Probably not. What about this? It's hard to say. Let's define what a streak is as a series of games with one of the possible outcomes being the dominant elements of said series. For example, this is a win streak, whereas this is somewhat of a win streak, then this is somewhat of a lose streak. This is not a streak. Now let's suppose there are 3 matchmaking algorithms: perfect matchmaking, near perfect matchmaking, and streak matchmaking. Perfect matchmaking is an absolutely perfect matchmaking algorithm that guarantees a 50% win rate per game. Near perfect matchmaking is a matchmaking algorithm that guarantees a 50.1% win rate. Streak matchmaking is a matchmaking algorithm that first decides a type of streak for a player. Let's see how each matchmaking algorithm pans out, assuming required net wins is 40. This is Paul. He's back again. If Paul were to play under perfect MM for him to achieve 40 net wins, he has to play as below in 5 different simulations, or an average of 7,060.8 games. For 100 players, they ended up playing as below in 5 different simulations, or thousands if not millions of games on average. This is too much. We can only play 18,000 games per year, physically. Let's use a more lenient matchmaking algorithm. If Paul were to play under near perfect MM, for him to achieve 40 net wins, he has to play as below in 5 different simulations, or an average of 20,577.6 games. For 1,000 players, they ended up playing as below in 5 different simulations, or thousands but not millions of games on average. This is still a lot of games, but at least not that many people are playing millions of games, so it is an improvement. Remember this graph from a previous video? Similar to it, below is a graph of average number of games played per targeted win rate across 1,000 players. We should take note of these 2 points at 51% and 53%, as the games played are within a reasonable range. Let's try Streak MM. But first, how does it work? When a player queues up, either a win streak or a losing streak is selected randomly with a predetermined probability. The assigned streak will last for a predetermined number of games. During a streak, the result of the game that corresponds to the purpose of the streak will be named as an event. In each streak, the event rate is always substantially higher than the counter event rate. When the player has fulfilled the streak duration, upon next queue up, a new streak will be decided regardless of the previous streak. For example, if Paul queued up, step 1, by a 50% streak chance, he is put into a lose streak. Step 2, the lose rate, which is the event rate, will be 85%. Step 3, the win rate, which in this case is the counter event rate, will be 15%. Step 4, this streak will continue for 6 games, the streak duration. Step 5, Paul finishes 6 games and queues up again, back to step 1. If Paul were to play under Streak MM, for him to achieve 40 net wins, he has to play as below in 5 different simulations, or an average of 54,964,618.8 games. Fun fact, it would take 15,000 plus years to play more than 274 million games as seen in Simulation 5. For 1,000 players, they ended up playing as below in 5 different simulations. The fact that there is still a huge number above a million is not ideal. This happens when a lose streak is followed by another one for multiple times past the point of recovery, well below zero. A bottom for net wins may be applied to soften the impact of consequent lose streaks. To solve the issue of some players having to play millions of games, a bottom for net wins was applied to soften the impact of consecutive lose streaks. If a player's net wins falls below a preset value, it will be reset to that given value regardless of how many losses are to come. This protection will last until the amount of net wins bounces back above the threshold. If Paul were to play under Streak MM, for him to achieve 40 net wins, he has to play, as below, in 5 different simulations, or an average of 616.8 games. For 1000 players, they ended up playing as below in 5 different simulations, or an average of 543.41 games. With different values for the safety, -10, -20, -30, -40, when the safety bottom is set to -10 net wins, for 1000 players, they ended up playing as shown in 5 different simulations, or an average of 763.49 games. With the safety bottom at -20 net wins, the 1000 players ended up playing as shown in the table in 5 different simulations, or an average of 1008.38 games. They played an average of 1284.03 games when the safety bottom is set to -30 net wins. And lastly, when the safety bottom was set to -40 net wins, the average number of games across 1000 players increased to 1488.17 games. It seems that a decrease in the bottom by 10 net wins usually results in an increase in the average number of games played by 200 to 300 games. Also, now the average number of games played is somewhat physically feasible, from 500 to 1500 games, which is within the range that we saw previously from this graph. Happy grinding, more videos coming soon.